Hi everyone, welcome to our presentation, Bioplastic Robotic Materialization, Digital Design and Robotic Production of Biodegradable Objects. I'm Mostafavi from TU Delft and the Saar Institute of Architecture, where I lead DARS Design Studios.
My name is Kretzer. I'm professor for material and technology at the Dessau Department of Design and director of the Materialization Research Group at the Anna University of Applied Sciences. This was a collaborative course in between the design department and the Dessau Institute of Architecture in 2018 and 19. So, as many of you know, plastic is a big problem on our planet. The global annual plastic production is about 300 million tons. 50% of that is only for single-use purposes, so it's only utilized for a very few moments and then still remains on our planet for up to 1,000 years. In summer, it's estimated that around 55% of the global plastic is actually discarded. A quarter of it is incinerated, and only 9% of it is actually recycled. So in order to solve this problem or approach this problem, one solution could be to look for more sustainable resources, such as bioplastic, which are composed of renewable organic biomass sources, which means that they're inherently biodegradable. And on top of this ecological advantage, they also allow us to help conserve fossil raw materials in our dependency on mineral oil. Generally, plastics can be described using a very simple equation. They are made from a polymer, from plasticizer and additives. The polymer gives the plastic its strength. The plasticizer is for its elasticity or plasticity, and the additives add different additional properties such as color, durability, and reinforcement. So as a rule of thumb, if you want to make your own bioplastic, adding less plasticizer will make a more harder material, and more plasticizer will create more flexible and softer material. There are various different recipes in order to make your own bioplastic. They're all very straightforward. One of the most common methods is using gelatin, but you can also use starch, milk, cream, or even algae as a substrate to create bioplastics.
Next to this material research, the idea was to use digital design and robotic fabrication in order to be able to produce these biodegradable objects digitally. So we were using different additive, subtractive, and cutting manufacturing techniques in order to be able to, on one hand, consider the material properties and also consider the potentialities and constraints of different fabrication techniques. So in these collaborative setups, the students from different disciplines from design and architecture were working closely together, and also they were learning different skills in order to basically use this hands-on approach to, on one hand, hack the material, and on the other hand, also master digital design and fabrication techniques. So the studio resulted into different projects. Here we are presenting 4 projects in this project called Second Skin. The idea was to use thermochromic pigments in order to use basically body temperature data, which result into changing the color of this variable. So the idea was to use different pigments and different additives in order to be able to achieve different flexibility and stiffness, which result into these 2 larger scale prototypes. And as you can see here, they developed an interesting design to robotic production workflow where we are cutting this 2D material in order to be able to basically bend it over the body following a specific pattern of porosity. In another project called Lifelight, the main, let's say, fabrication research was using additive manufacturing, but at the same time, they had this idea of using personal data such as DNA in order to sort of customize and individualize these objects. And at the same time, they were running different tests and tryouts in order to hack the material, in order to understand the way we can work with this material when it comes to additive manufacturing. And the idea was to use basically this as a kind of a desk light where you can see how the light is coming from under the object. And in this video, as you can see, we were running several tests in order to adjust the design guidelines and set basically design and production guidelines for different design variations. And at the same time, the idea was to learn from the failures and based on this failure, adjust the way we can work with this material in order to achieve better results.
Another project is called Fruit Lamp. Here the idea was that using this biodegradable material, the object could be directly integrated into nature, and then whilst using it, it would start decomposing itself over the cycle of its life. They also incorporated a mechanical pulling mechanism, so there's no need for external electricity. And the final project is called Aroneo. Here the group looked at light pollution and light consumption, especially in Germany, and they came up with this idea of adding phosphorescent pigment into the bioplastic structure. So they would create these spiderweb systems, which could then be incorporated into the urban streetscape and charge themselves during the day and give up a subtle glow at night. We have a final video of the project. Thanks for listening, and I hope you enjoyed our presentation.
Together with design faculty of the SAU and architecture faculty, we are conducting a collaborative course titled Bioplastic Robotic Materialization, in which we are bringing designers and architects together.
The interesting idea behind this project is not only that we're merging these disciplines, but also that we're employing cutting-edge production techniques.
Then using parametric modeling or generative design methods that consider the developed production methods and the customized material, we design and robotically produce biodegradable lamps.
So depending on how we want the lamp to look, we can create a material which has a particular transparency, which has a different color, which has a certain flexibility or stiffness.
Beyond this interdisciplinary experience, which happens during this semester, we believe that we are preparing ourselves for today's and near future societal and environmental challenges.
So far it has been great fun, and I hope that this project is just the beginning of much more collaboration in between these two faculties here at the campus in Dessau at the Bauhaus. And if you want to keep up to date on our collaborations and other work we do, please follow us on Instagram or visit our website. Thank you.
Thank you very much.